We have already published a longer video with background information about the different instruments and several short YouTube videos about the James Webb Space Telescope. Now, the first pictures of the infrared telescope have been published, and what can we say? Webb lives up to all expectations, and space fans can look forward to countless more outstanding pictures in the following years. Webb has already been hit by a micrometeorite, travelled a long distance to get to the target point after launch, and the telescope calibration took several months. However, the test images taken during commissioning already show a significant improvement in quality, like this test of the MIRI instrument from Webb compared to a picture from the Spitzer Space Telescope. But this image of Jupiter and its moon Europa, also taken during commissioning, is interesting, as it shows that Webb can also help uncover the secrets of our solar system. Let's move on to the first real images of the James Webb Space Telescope after calibration is complete. The most impressive image shows NGC 3324 in the Carina Nebula, which is visible from the southern hemisphere. This image reveals previously invisible areas of star birth for the first time. NGC 3324 is located at a distance of about 7,600 light-years and was imaged with Webb's near-infrared camera, NIRCam, and mid-infrared instrument, MIRI. It is the edge of the giant gaseous cavity in NGC 3324, and the highest peaks in this image are about 7 light-years high. Webb reveals nascent star-forming regions and individual stars that are completely hidden in visible light images. Thanks to its sensitivity to infrared light, Webb can see through cosmic dust to detect these objects. Protostellar jets shoot out from some of these young stars, which are clearly visible in this image. The youngest sources appear as red dots in the dark, dusty region of the cloud. Objects in the earliest, rapid stages of star formation are difficult to detect, but Webb's sensitivity allows him to record them. The observations of NGC 3324 will shed light on the process of star formation. This continues over time, triggered by the expansion of the eroding cavity. As the bright, ionized edge moves into the nebula, it slowly pushes into the gas and dust. When the edge encounters unstable material, the increased pressure will cause the material to collapse and form new stars. Webb will address some of the big, unanswered questions in modern astrophysics. What determines the number of stars that form in a given region? Why do stars of a certain mass form? The next image shows Stephan's Quintet, a visual grouping of 5 galaxies that is best known for the classic movie It's a Wonderful Life. This huge mosaic is Webb's largest image to date, covering about 1/5 the diameter of the Moon. It contains more than 150 million pixels and was assembled from nearly 1,000 individual image files. Webb's information provides new insights into how galactic interactions may have driven the evolution of galaxies in the early universe. The 5 galaxies of Stephan's Quintet are also known as Hickson Compact Group 92, HCG 92. Although referred to as a quintet, only 4 of the galaxies are truly close together and involved in a cosmic dance. The 5th and leftmost galaxy, NGC 7320, is clearly in the foreground compared to the other 4. NGC 7320 is 40 million light-years from Earth, while the other 4 galaxies, NGC 7317, NGC 7318A, NGC 7318b and NGC 7319 are about 290 million light-years away. Two cameras aboard the Webb telescope captured the latest image of this planetary nebula, catalogued as NGC 3132, and are informally known as the Southern Ring Nebula. It is about 2,500 light-years away. Webb will allow astronomers to explore many more details about planetary nebulae like this one. Clouds of gas and dust ejected by dying stars. Understanding what molecules are present and where they are located in the gas and dust shells will help researchers refine their knowledge of these objects. Each shell represents an episode in which the fainter star lost some of its mass. The widest gas shells in the outer regions of the image were ejected earlier, and those closest to the star are the youngest. Tracking these ejections allows researchers to look at the system's history, especially since planetary nebulae have existed for tens of thousands of years. The James Webb Space Telescope has captured the distinct signature of water, as well as evidence of clouds and haze, in the atmosphere of a giant, hot, gas planet orbiting a distant, sun-like star. The observation, which reveals the presence of specific gas molecules based on tiny brightness decreases of precise light colors, is the most detailed of its kind to date and demonstrates Webb's unprecedented ability to analyze atmospheres hundreds of light-years away. While the Hubble Space Telescope has analyzed numerous exoplanet atmospheres over the past 2 decades and provided the first unequivocal detection of water in 2013, Webb's more immediate and detailed observation represents a major advance in the search for potentially habitable planets beyond Earth. WSP-96b is one of more than 5,000 confirmed exoplanets in the Milky Way. It is located at a distance of about 1,150 light-years in the southern constellation of Phoenix. With a mass less than half that of Jupiter and a diameter of 1.2 times larger, WSP-96b is much more bloated than any planet orbiting our Sun. And with a temperature of more than 540 degrees Celsius, it is also much hotter. WSP-96b orbits its Sun-like star extremely closely, much closer than Mercury in our solar system, completing one orbit every 3.5 Earth days. In June 2022, Webb's Near-Infrared Imager and Slitless Spectrograph, NIRISS, measured the light from the WSP-96 system for several hours as the planet moved around the star. The result is a light curve, showing the overall attenuation of the star's light during the transit, and a transmission spectrum revealing the change in brightness of individual wavelengths of infrared light between 0.6 and 2.8 microns. This revealed hidden atmospheric details, such as haze and clouds, as well as the distinct signature of water. The latest image from the James Webb Space Telescope has provided the deepest and sharpest infrared image of the distant universe to date. Webb's first deep field is the galaxy cluster SMACS 0723, as it appeared 4.6 billion years ago, teeming with thousands of galaxies, including the faintest objects ever observed in the infrared. The concentrated mass of this cluster of galaxies acts like a gravitational lens, magnifying more distant galaxies, including those observed when the universe was less than 1 billion years old. This deep field, captured by Webb's near-infrared camera, NIRCam, is a composite of images taken at different wavelengths for a total of 12.5 hours. And that's just the beginning. Researchers will continue to take more images with Webb to reveal even more of our vast universe. You can clearly see the improvement this telescope brings. And if you enjoyed this video, subscribe to our channel.